everyone, thank you for watching this video. This part of today's lesson, right, we're going to look at revision for similar triangles, right? We have learned this concept in Sec 2 and also in Sec 3. So here's going through some of the main concepts through the use of 4 simple questions in this worksheet. Okay, let's take a look at the first question, right? In the following figures, triangle ABC is similar to triangle PQR. Now, this is already given. So when you have a pair of triangles that are similar, they have usually two properties. Number one, the ratio of the matching sides are the same. Number two, the angles, all the different angles over here. So all the different angles will have the same matching angle, corresponding angle. So before we start off, right, the usual thing that we need to do is to be able to find the matching points, right? So for example, I have triangle ABC. It says that it is similar to triangle PQR. That means the angle for A will match with the angle for P. So if angle A is 35, angle P will also be 35 degrees. Okay, then B matches with Q, so B will match with Q, so B is X, so in this case, X will be equals to 25 degrees. Okay, and last but not least, angle C with angle R. Okay, so they are matching. So once they have a matching, you match the different sides already, right? What you can do now is you can also write down the ratio of the corresponding sides using the matching lengths. So if, for example, okay, I want to find the ratio, let's say I have the ratio of AB. Okay, AB will match with, I'll take it as AB over, will match with the side PQ. Okay, and this ratio is the same as another one more matching pair. Wait, let me write down in highlighter, AB with PQ. Okay, and then we have the next matching side, maybe BC. BC will be with QR. BC with QR. Okay, I'll take the pink. B, C, and Q, R. And last but not least, one more matching side. Okay, on this case, I will have AC with PR. Okay, one more matching side. So AC is the blue one with PR. So for us, when we write the ratios, right, we must remember all the sides on top are from the same triangle. Okay, all the sides below are from the same triangle. In this case, I have the triangle ABC on top and the triangle PQR below, right? So they all belong. So now I have the ratio of the sides already, and I want to find the values of the unknown. Just now I already found the angle for X. So let's write down the answer. X equals to 25 degrees. So the value X will be just 25. Secondly, let's fill in the ratio of the sides that we have. AB over PQ, AB over PQ. That means we have the ratio 12 over H. BC over QR, BC is the pink color side, over QR is K. And AC is 6 over PR is 4. So what can we do to find the values for H and for K? We use a pair of matching sides first. So I'll use the first one, 12 over H. I'll use it with the side that already has values. So this side has all the values, 6 over 4. So I'll equate this to 6 over 4. Okay, and then we cross multiply to find out the answer. And then we divide by 6 to find the value for H. Okay, then we'll look at the second pair of ratio. Again, I know that this is given, so I'll find 9. I'll use this for 9 over K with 6 over 4. Okay, cross multiply, 6K 36. K will be equals to 6. Have you gotten the answer? So concept number one, all the matching angles for similar triangles are the same corresponding angles, or the ratio of the corresponding sides are the same. So it's actually important to be able to write the ratio of the matching pairs. All right. Okay, now let me move on to the next question, the next few concepts. Okay, inside this diagram is given that BC is parallel to DE. Show that the triangles ABC and ADE are similar. If you're going to show that they are similar, the easiest property or whichever that we'll need is to find at least two equal angles, matching corresponding angles. So first one, I need to know that there is a sequence in the order of the labeling. They want triangle ABC. I need to match it with triangle ADE. We can start with the angles first. So in triangle ABC, angle B over here is supposed to match with angle D. And in fact, these two angles are equal to each other. And what is the reason so? Because of a pair of parallel lines, right? We have a pair of parallel lines over here. This pair is parallel. So we have actually corresponding angles on parallel lines. So we need to write it down. The first angle, angle ABC, equals to angle ADE by the reason, right, corresponding angles on parallel lines. So we need to write the reasons. Then our job now is left with finding one more angle, matching angle. So I can see that E and C, so angle ACB is equals to, there's a sequence in the order of labeling, A, C, and then B, then that will be A, E, and D. This pair of angle is also the same, so it's by the reason corresponding angles on parallel lines. Then we write that since two angles, corresponding angles are equal to each other, therefore, triangle ABC is similar to triangle ADE. I repeat again, the order of the labeling is important. So the different points must be able to match with one another. Okay, so then we move on to part B of the question. So part B itself, given that BD is equals to 2 times of DA, what does this actually mean? BD is 2 units over here, DA will be 1 unit. So BD is twice of DA, right? So from here, we can also see a pair of ratio, right? We can have from the similar triangles itself, the ratio of the small triangle over the big triangle. I should begin, right, with the small ones. So the first one will be AD over AB. This is equals to the next pair ratio, ADE over BC. The smaller triangle, DE over BC. This is also equals to ratio AE over AC. And from here, we can see that AD is 1 unit, AB is 3 units. So we already know that this one over here, the AD itself, is 3 units. Okay, so in that case, if I want to find the ratio of DE over BC, which is over here, DE over BC, this has the same ratio as AD over AB, which is actually the answer now given on the diagram, 1 over 3. So this one will be my answer for B, part 1. Next, we're going to find the area of triangle ADE, given that the area of the trapezium is so much and so. So now when we come to this part of the question, we need to realize that A, they are similar triangles. The ratio of the area of similar triangles, okay, I only know the length. The ratio for length of the small one over the ratio for the length A over the length for the bigger triangle. From what I know earlier on, the ratio of the length is 1:3. But if I want to find the ratio of their area of small triangle over area of the big triangle, okay, what do I need to do? I need to take the ratio over here and square it. So area is cm squared, right? So it's square it. So I take 1/3 whole thing square, that will give you 1/9. Let's observe the area of the small triangle. Small triangle has the name ADE, and the bigger triangle is ABC. So this one is triangle ADE over triangle ABC. Then how does this help me to relate to the area of the trapezium? Right, but the trapezium over here is this area, right? How can we find the area of the trapezium? Area of trapezium is to take area of triangle ABC, the larger triangle, area of triangle ABC, minus away the smaller triangle ADE. So according to my number of units here, the small triangle is 1 unit square. Then the area of the larger triangle is whole thing is 9. So that means this area over here will be smaller, will be the 8 units square, right? So this one is 1 square unit. Okay, number of units, they are just the units only, not the actual length itself or the actual area itself. So what I can see that the area of the trapezium is 8 units over here and is given to be 136. I want to find the area of triangle ADE, which is a small triangle. Small triangle only have 1 unit, so ADE is only 1 unit. So what I need to do, 8 units represent 136 cm square, and I find 1 unit, that will give me 136 divided by 8. 17 cm squared. Have you gotten the concept? Okay, so area of triangle ADE, 17 cm squared. Let's continue to the last 2 questions. Okay, question number 3, inside this diagram, they give you that angle ABC over here, okay, ABC is equals to angle ACD. And I have a couple of different lengths. They wanted me to show that the triangles are similar to each other. Before I show that they are similar, let's try to find the matching pairs first. According to the triangle, the question, it says ABC and ACD. Let's try to match whether is it true or not. A with angle A. Where's angle A? Angle ABC. Oh, this is angle A. And angle CAD. Oh, this is also angle AA. They share a common angle. They are the same exact angle, correct? So in this case, I'll write down the first reason. To show similarity, I just need how many angles? I just need 2 angles to be equal to each other, right? So the first one, I'll choose maybe BAC equals to the angle D, if it's BAC, that'll be CAD. BAC, CAD. Right, so this is given, this is not given, but they are the same because it's a common angle. Okay, secondly, I need one more angle. They already gave it to me. Angle B is equals to angle C. Oh, this one is already given to me, so I should write it down. ABC equals to angle ACD given. Then we write our favorite sentence, since 2 corresponding angles are equal, therefore triangle ABC is similar to triangle ACD. Have you gotten the concept? So now we know that the last but not least, point C over here, this one, point C, will match with point D. Point C will be angle ACB. Oh, this point C, ACB to ACB to match with angle ADC. ADC. Oh, this is the angle. Okay, so they are matching. Okay, but maybe we might need it later. Now, next part B, they asked me to find the length for AB. Oh no, now when they want to find length, right? What do we need to do? We need to start labeling down all the different ratios or different sides first. So I'll start off with AB over AC. So let me just write it down first. AB over AC equals to the next pair, BC, sorry. BC with CD. And last but not least, AC with AD. Okay, so I have all the triangles ABC on top and all the triangles, the sides of the triangle ACD below, right? So let's fill in some numbers. What do I have? I don't have the length for AB. Okay, I do not know. So AB is just AB. AC is given to be 6 cm. BC, I do not know. CD is, I also don't know. AC is 6 and AD is 4. Hence, from here, we can use these two ratios to help me to solve the equation to find the value, right? So in this case, I have AB over 6 to be equals to 6 over 4. Let us do cross multiplication. For AB equals to 36. AB will be equals to 36 divided by 4, 9 cm. Have you gotten your answer? Next one, part C, we're going to find the ratio of angle ACD over here, and angle triangle BCD, OBCD over here. So what do we notice about the two triangles? These two triangles lie side by side each other. They share a common side, okay, or rather, in fact, they actually have a common height. Right, 90 degree. Let me just draw the H over here. If this is going to be height, then the base for the triangle ACD will be here, and the base for triangle DB will be here. But I don't have the length for DB, but I do know AB just now. So AB was given to be 9 cm. The whole thing is 9. So this part over here, BD, will be 9 minus 4. That will give me 5 cm. Okay, so area of triangle, let me do part C, yeah. Area of the triangle ACD over area of triangle ABC can be found by half times base times a height, half times the base times the height, since the two of them have common height. So now we're going to look at the base. The ratio of base will be 4 over 4. ACD is 4, ACD, yes. Then ABC, they want ABC. ABC will not be 5 cm. ABC is the whole thing. ABC is the whole triangle. So this one will be 9 cm. Oh, luckily read your question. Okay, so in this case, ABC will be 9 cm, right? So in total, I will have ratio 4 over, answer will be 4 over 9. Because the rest over here can cancel away. I'm just writing down the working for you all to see, okay? Next one, part D, find the ratio of area of triangle ACD over BCD. So if I want to find the ratio of triangle AB, wrong way. Oh yeah, sorry, look at the wrong question. So I want the area of triangle ACD over BCD. ACD and BCD, again, the two triangles lie side by side each other. They share a common height in between. They are leaning against each other, right? So if I want ACD, the base for ACD, the smaller one will be 4. And BCD now, So the other side, this length will be 5. So we can still use the same concept. So area of triangle ACD over area of triangle BCD is equals to half times 4 and times h and half times 5 times h. So after cancellation, this will be 4 over 5. Okay, have you gotten the concept? Now, just to highlight one of the questions over here, for question C itself, you realize that at the same time, other than that, the two triangles are leaning side by side or they share a common height itself, they are also actually similar. So when we have similar, right, we should actually use the ratio of the length. We could use the ratio of the length and we square it. So we notice that the ratio over here, this can be simplified to 3 over 2, right? But the ACD is the smaller triangle, so the length for the smaller triangle is 2 units, and ABC is the larger triangle, so the length for the larger triangle will be 3 units. But since we want to find the ratio of the area for similar triangle, when we want area, we need to square this ratio, and you still get the number 4 over 9. So indeed, this has the same concept over here. This is just a different method for getting the same answer, okay, for part C. All right. Okay, if you've gotten the answer, let us do the last question for this part of the video, for this lesson. Right? Question number 4. Inside this diagram, it's given to you that ACB, angle ACB over here, this angle is equals to angle ADE. So they want us to show that the two triangles are similar. So even before we begin, let me try to match the side AC and B, the bigger triangle, to match with AD and E. Okay, let's look at angle A, angle BAC. BAC is over here. And angle EAD. EAD, also the same angle. So since the question asked me to show that they are similar, I need to show two corresponding angles are equal. So I should write down my first angle, angle BAC equals to angle EAD. The reason because it's the common angle. Right, it's overlap, right? So they are the same angle. And then we have given to us already angle ACB is equals to the angle ADE. This is given to us. So since we write our statement, two corresponding angles are equal, therefore triangle ACB is similar to triangle ADE. Have you gotten the answer? Part B, let us find the length of CE. Now we're going to involve something to find length. So I show you to do my usual. Let me write down the ratio. AC over AD equals to BC over ED. And last but not least, AB with AE. Notice all the ratio on top are sides for triangle ABC. All the below are all the sides for triangle AED. Right? Let's fill in measurements. AC, I do not know AC. Okay, AC, I don't know. AD is 5. I only know part of AC, right? Then BC don't know. ED also don't know. AB, how much is AB? AB is 5 plus 2, 7. AE is 3. So we actually have a pair of sides. Okay, the question asked me to find CE. There's no CE in my expression. Okay, but CE is on the side involving AC. So what can I do? I can probably find AC first. And in this case, I have this matching one over here, this number. So I'm going to use this to find AC. So AC over 5 equals to 7 over 3, cross multiply. 3 times AC equals to 35. AC will be not a nice number. I should leave it as a fraction. 35 divided by 3, 11 and 2 over 3 cm. Okay, this is the exact answer. I try not to round it off unless very necessary. But then if I want to find CE, I'll need to take 11 2 over 3. The whole thing is 11 2 over 3. This is given to me 3 cm. So in order to find this portion, I need to subtract. And that gives me 8 and 2 over 3 cm. Have you gotten the answer? 2. Now they want me to find the area of triangle ADE over the area of triangle ABC. They are no overlapping, okay, maybe some sides, but do not have a common height. So I do know that they are actually similar to each other. So when the triangles are similar, we should take the ratio of their length. Okay, the ratio of length is 7 over 3. The larger triangle is the larger length is 7. The smaller length is 3, but they want the ADE is the small, right? So I write 3 over 7. I'll take the ratio of the length, but whole thing we need to square area, right? We'll square to get area, so that will be 9 over 49. Have you gotten the answer? Okay, if that's the case, with that, we've come to end of this part of our revision video, right? I hope you look through the concepts for similar triangles again. Right, I'll see you for the next video. Goodbye.